Hello, Mastery Algebra 1. Welcome to the quadratic family. This is going to be lesson 9-1, quadratic graphs and their properties. What we're doing now is we're looking at the family of quadratic functions where the rate of change is not constant. So if you remember back when we looked at linear lines, we had a constant change of rate. No longer do we have that with quadratics. The graph uses a smooth curve now, with a highest and lowest point being used as a maximum or a minimum. Okay, and these graphs, which we have seen before, are called parabolas. So key concept, the standard form of quadratic. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a, b, and c, okay, these are just coefficients or numbers. Now, we cannot have a equal to 0, because if a equals 0, we would get y equals bx plus c, and then this is, if you remember, a linear line. So the standard form of a quadratic is y equals ax squared plus bx plus c. Some examples, we have y equals 3x squared, we have y equals x squared plus 9, and we have y equals x squared minus x minus 2. More information, the highest or lowest point of a parabola is its vertex, which is on the axis of symmetry. For instance, we're going to get a parabola. Okay, if the a term, this a term being right next, or the coefficient right next to the x squared, okay, if a is greater than 0, for instance, if we have y equals 4x squared plus 2x plus 1, okay, this coefficient right here is the a term. Okay, if 4 is greater than 0, then we have a parabola that moves upward or opens up. This point right here at the bottom of the parabola, this is our vertex. Okay, and it lies on this line that splits this parabola into two, and that is called our axis of symmetry. We can also abbreviate the axis of symmetry as our AOS. If, over here, if a is less than 0, as in y equals x squared plus bx plus c, if our example is y equals negative 2x squared plus 3x plus 1, okay, this a right here is negative 2. So if a, which is negative 2, is less than 0, okay, now we're going to get a parabola that opens downward. So here's our vertex here. This is going to be a maximum point, whereas the one before was a minimum point. It also, again, being that it's a maximum point, it still lies on that axis of symmetry that splits that parabola into mirror images. So problem one, we're going to identify the vertex given a graph. What are the coordinates of the vertex of each graph? Is it a minimum or a maximum? So if we look at A, we see that it is a parabola that is opening downward. The highest point on this graph is about right here. This vertex is a coordinate. The coordinate is 0 on the x. And if we go up 1, 2, 3, so we get 0, 3. So the vertex is 0, 3. And because it is opening downward, it is a high point. Since the vertex is the highest point, we call that a max, or a maximum. On B, we notice it's opening upward, so the vertex is down here. Okay, it is the lowest point, so we know we have a minimum, and the vertex now is going to be the coordinates. Well, it goes through 0, 0, so if we go over 1 and down 1, we have 1, negative 1 as the vertex, and it is a minimum. Next question then asks us, what is the equation of the axis of symmetry for each graph above? Remember, your vertex goes through the axis of symmetry or lies on the axis of symmetry. So it is this, if we look at A, where this red line comes down the middle, there is our axis of symmetry. Notice, if we think back to linear lines, it is a straight up and down line. Any line that is vertical, if you remember, has undefined slope and is also goes through the x-axis. So all axes of symmetries are x equals, and then we look at where does it go through. Since our vertex, the x-coordinate is 0, this first one on A is x equals 0. On B, We know the axis of symmetry runs through this vertex point. We know it goes through, looks like 1, and the vertex lies on 1, -1. So our x equals the x-coordinate, which is x equals 1. Now you try. So what is the vertex of the graph at the right? Is it a minimum or a maximum? And also draw in the axes of symmetry and label what it is. Go. All right, welcome back. If you notice, you have a minimum right here. Okay, our vertex was, yes, -2, -3. And -2, -3 goes through and lies on that axis of symmetry. It is the vertical line at x equals -2. Congratulations. All right, problem 2. We're looking at graphing y equals ax squared. We're going to graph the function y equals x squared. We need to make a table of values, and then what is the domain and range? The way we can start this is we can draw in we're looking for x's. Draw like a table. We have y equals x squared, which is what we're plugging into. And then we're going to find some point to graph. Okay. Well, if we're looking for where to start, okay, we can let's start with one of the easiest numbers. So let's start with 0. Okay, if I square 0, we're going to get 0. So our point is 0, 0. If we just go from there and stick with, let's go up a couple numbers. So 1, 2, 3. So we're going to square 1. So that's 1. So now we have a point that's 1, 1. If we square 2, we're going to get 4. So now we have another point that's 2, 4. And if we square 3, we get 9. So our point is 3, 9. So if we go over and we plot those points, if we connect them, and notice that 9 is off the graph, but I just drew it for reference. Okay, remember, we have a quadratic. Okay, what's a quadratic supposed to be? It is a parabola. If we go back to what we just looked at, remember, we are looking at a. Okay, the a term, which is right here. Well, I don't see a number, so you have to assume, remember, that if the number's gone, then the number we always have in front is a 1. So this is really 1 times x squared. Since it's a positive, okay, or 1 is greater than 0, we know that this opens up. So remember, the vertex was a minimum. Now, if you look at the points that we just graphed, okay, we don't have a full parabola. We only have almost looks like a line. So what we need to do is we need to go on the other side and graph some negatives just to complete the parabola. So from 0, let's plug in -1, -2, and -3, which we're squaring. So when we go -1 squared, we're going to get 1 again. When we go -2 squared, we're going to get 4 again. And when we go -3 squared, we get 9. So our next set of points are -1, 1, -2, 1, 4, and -3, 9. So by graphing those and connecting the dots, we now have a parabola that opens upward and has a vertex right here in this green. Okay, our vertex, which is 0, 0, okay, and it is a minimum. So what we have to figure out is, what are the domain and range of this? Remember, domain is our set of x's. Okay, so we got to figure out, if I start at the vertex, if I start here at 0, 0, okay, and I go this way to the left, how far can I go to the left and still go up to some point? Now remember, we only did -3 to +3, but we could do infinitely many points or x values. So I could go out to -4 and go up, -5 go up. What's going to happen is this graph is going to get really, really, really skinny, but I still could go out as far as I possibly can to the left. Well, the same is true to the right. If I take these x values and I go out to 3, 4, 5, 6, 7, 8, I can still square all of those. So you could go up to a point that's really, really high and still graph the point. So in this case, when we go anywhere to the left or all the way to the right, we're going to say that the domain is all real numbers. Now when we look at the range, if you remember, the range was the set of y values. I notice that in this blue, if I look on the y-axis or the vertical, the lowest point, if you remember, the lowest point is 0, because it is a minimum, and it goes through that vertex. So if my lowest point is 0, 0, and then anything up could still go to the graph, then I know that my set of y's has to be greater than or equal to 0. All right, next page. Problem 3 says, now we're going to compare the widths of the parabolas. How do we know when one is wider than the other? Well, the formula that we're going to use, or really no formula at all, is we're going to look at the a value. So in the y equals ax squared part, plus bx plus c, this a is going to help us determine if it's wide or narrow. If you remember, if it were negative, so if this were negative ax squared, we know it opens down. If it's positive ax squared, we know it opens up. So the negative part, whether it's negative or positive, that just determines if it goes up or down. Right? The actual number or coefficient that we have, if we take the absolute value of a, so the absolute value of negative a gives us a, or the absolute value of a gives us a, when we finally look at this, this is going to help us determine if it's wide or narrow. Numbers that are greater than, again, 1 go really, really steep or really, really high. They narrow the graph. So anything that goes from 1 to 2 to 3 to 4, as we go up in numbers, we know we are getting a skinnier graph. As they go down below 1, get closer and closer to now 0, we know that's going to take longer, so they're going to be wider. So when we have here, when its absolute value of a is greater than 1, we get a skinny graph of something that shoots really, really high or goes down quickly. If it is between 0 and 1, then we get a wide graph that goes up and out, or starts with a maximum and goes out. So if we look at the functions, what is the order from widest to narrowest of the graphs? We have f of x equals negative 4x squared. We have 1/4 x squared, and we have x squared. So let's take the absolute value of those. So we're going to say negative 4 is the coefficient a. Okay, we're going to take the absolute value of negative 4, and we're going to get 4. We're going to take 1/4, take the absolute value, and we get 1/4. And if we take, remember, there's a 1 in front. So if we take the absolute value of 1, we're going to get 1. So we want to label these from widest to narrowest. So remember, the widest graph is going to be that graph that is a little bit closer to 0, or closer to 0 compared to the other ones. And that's going to be, our answer is 1/4. So we know that the widest graph is f of x is equal to 1/4 x squared. We know that the lowest graph, we know that the steepest graph, or the skinniest graph, or the narrowest graph, the first one that we started off with, negative 4x squared. Okay, so that means that the one in the middle is f of x, which is equal to 1x squared. So that's labeling from widest to narrowest. All right, let's look at the got it. Go ahead and pause. I want you to label the 3 functions from widest to narrow, and then check your answers when you get back. Go. All right, welcome back. If you notice, you should have had f of x equals negative 1/3 x squared. This is the widest, so that's the first one. Then the second one becomes f of x equals negative x squared. That was the next widest. And the last one, which was the skinniest, was this y equals 3x squared. All right, on to number 4. When we look at graphing, y equals ax squared plus c. Okay, we want to find out, and this is a multiple choice test, how is the graph of y equals 2x squared plus 3 different from the 2x squared? Well, without even looking at the graph or even the table, if we concentrate on this 2x squared part, okay, remember, both are positive, so we know both go up. The a term, which is 2, so a equals 2, they both have the same width of the graph. The only thing different is this plus 3. So when we look at the table, okay, we inputted negative 2, got 8 for the 2x squared, but then get 11 for the 2x squared plus 3. When you plug in negative 1, we get 2, and then for the other one, we ended up getting 5. Well, if you notice, each of the y values for the 2x squared plus 3 are 3 more than the corresponding y value on the 2x squared. So what's happened to this graph? Well, if you notice this first one, which is the red, okay, so this was the original, which was the 2x squared. Okay, now the blue one basically has the same shape, it is just shifted. In other words, if we look at this vertex, where's the vertex? The vertex has shifted how many? The vertex is shifted 3 units up. So that is A. The graph is shifted 3 units up. All right, so the last problem, what you want to do is you want to hit pause. You want to graph y equals x squared. You want to graph y equals x squared minus 3. Tell us, how are these graphs related? And check your answers to make sure that the work is correct. Go ahead, hit pause, go. Alright, welcome back. If you notice by making two tables over here, again, we had already done y equals x squared, but we need to figure out, just randomly test a point. Make sure you, start at 0. I just ended up starting at -2 for a couple. So I did -2, -1, 0, 1, and 2. When you square those, you get 4, 1, 0, 1, and 4. So plugging in the red, we get this graph here that goes through 0, 0. Then by subtracting 3 from each of those points, which we get y equals x squared minus 3, we got the blue. So what has happened from the original graph, the y equals x squared, to now the next one? The blue vertex, if you notice from here, the blue vertex has shifted down. It is shifted down 3. Okay? Both graphs opened up. Both graphs had the same width. They had the same a term. Okay? So the only thing that has happened is they've shifted down 3. Hey, make sure, here's the bookwork for 9-1, page 550. Please do the problems in the blank space below or on a separate sheet of paper. If you do them below or on the back side of this, okay, make sure you pay close attention to your graphs. Make sure you draw them correctly to where you have spacing between numbers like this, and it is easy to plot the parabolas. Have a wonderful time, and remember, do your best, forget the rest. Bye for now.